notice. And this is the regular copyright. You have seen this before, and this. In video physics 06 and physics 07, we considered these 9 formulae here. And then in physics 08, we considered those 3 formulae there. So that means that we have covered 12 of these 17 formulae you see on the left here. And that leaves us with these 5 in yellow. Now we will concentrate on these 3, 1, 2, and 3, after which we will consider 10 and 11. Formulae 1, 2, and 3. These are called equations of motion because they deal with moving bodies. Now remember, in physics, a body is any object at all, absolutely any object. In all 3 of these formulae, the symbols represent the same quantity using the same units. T is time in seconds. Example, T is equal to 45 seconds. A is acceleration, and that is measured in meters per second squared. Example, A is equal to 4 meters per second squared. U is the initial velocity of a body, which is measured in meters per second. Example, U is equal to 2 meters per second. V is final velocity in meters per second. Example, V is equal to 8 meters per second. And S is distance measured in meters. Example, S is equal to 165 meters. So let's look at our first example. A car accelerates from 4 meters per second to 10 meters per second in 2 seconds. Calculate its acceleration. We will assume that the acceleration is uniform. Let us write what we are given. We know that U is equal to 4 meters per second, V is equal to 10 meters per second, T is equal to 2 seconds. We want to find A. Let us consider these 3 formulae up here. We will begin with the first one. We want to find A. Do we know U, V, and T? And the answer is yes. So we will use that formula. We use the formula V is equal to U plus AT. We change the subject of the formula to make A the subject, which gives us V minus U over T. We substitute the numbers we are given, and we get 3 meters per second squared. Now, this is one significant figure, and that should be acceptable for CSEC examination. But just to make sure, you can write A is equal to 3 plus or minus 0.5 meters per second squared. Maybe not required, but just to make sure. And this format, 3 meters per second squared, correct to one significant figure, is not required by CSEC at all. Now, in this same question, you may also be asked to find the distance traveled during that time. We know U, V, and T. We found that A is equal to 3 meters per second squared. Now we want to find distance. So we know these, and we just calculated that last one there in yellow. We want to find the distance. We look at our equations here. 2 equations have S in them, this second one here and this third one here. But since this third one here has S as the subject of the formula, we will use that one. S is equal to ut plus half at squared. Do we know u? Yes. Do we know t? Yes. Do we know a? Yes. So we can easily substitute those numbers in there and we get 14 meters. Now recall that we said up here, all those numbers have one significant figure. 14 meters, that number has two significant figures. If we leave it like that, maybe CXC will mark it right, maybe they will deduct a mark. We know though that our answer should have one significant figure. So let's round off at the tens position and we get S is equal to 10. And since we are rounding off at the tens position, that uncertainty will be half of that tens position, which will be 5 more and 5 less. So our answer is 10 plus or minus 5 meter. That is the distance. Alternatively, you could have used formula 2 instead, though that requires changing the subject of the formula. We know V, we know U, we know A. We want to find S. Then we would have had to change the subject of the formula to make S the subject, whereas in equation 3, in formula 3, S is already the subject of the formula and we know all the variables on the right. So if we do that, we get V squared is equal to U squared plus 2AS. Make S the subject of the formula. Substitute for S, which would give us 100 minus 16 divided by 6, which would give us the same answer as we got over here. Always choose the easier way to do a question, because if you choose a harder way, you are more liable to make errors. Or example 2, a small metal ball is dropped from the top of a tower 30 meters high. Calculate 1, its velocity just before it hits the ground, and 2, the time it takes for the fall. You are to ignore air resistance and assume that G, gravity, is 10 meters per second squared. So what do we know? We know U, which is the initial velocity, is 0 because it is dropped. We know S, the distance, is 30 meters. We know the acceleration is 10 meters per second squared, which is the acceleration due to gravity. And notice it is not a negative 10, it is a positive 10. We want to find V. We look at our equations up here. This first one has a V, but it also requires a T. And we don't have T in this question. This second one here has a V, it has a U, it has an A, and it has an S. We have those here. This is what we want to find. So V squared is equal to U squared plus 2AS. Remove the square from over this side. We get V is equal to the square root of the rest of the stuff on the right hand side. We substitute and we get V is equal to the square root of 600. When we find the square root of 600, we get 24.49 meters per second. Now, all of these numbers that we are working with here, they have one significant figure. So we cannot leave our answer with 4 significant figures. We have to round off to one significant figure. And so we get 20 plus or minus half of the position where that 20 is, which is in the tens position. So that would be plus or minus 5 meters per second. Now that was the first part of the question, where we got 20 plus or minus 5 meters per second. That is the rounded off answer. But if we need this answer to calculate further down in the question, we will use this because we don't want to use a rounded off answer early in a question. So we will use this 24.49. We want to find the time. Now this first equation here has time in it. This last one here has time twice, which will make it more difficult. So let's use the first one. V is equal to U plus AT. If we make T the subject of the formula, then T is equal to V minus U over A. If we substitute the numbers we have, that is V, that is U, that is A, and we get 2.449 seconds. Again, the numbers we are looking at, the least significant figure is 1. So we have to round this off to one significant figure. Round off to one significant figure, and we get 2 seconds. Just to make sure that we identify where we are rounding off and what the margin of error is, we will add plus or minus 0.5 second. And this should be satisfactory to C. So we did both parts of this question. But note that in part 2 above, you could have used the third formula, which says S is equal to UT plus half AT squared. We want to find T. Now notice that T appears twice in this formula. We know S, we know U, we know A, so we can use that formula to find T. But this is much more difficult to do since you have to change the formula into a quadratic format where half AT squared plus UT minus S is equal to 0, and then solve for T, and we will only take the positive value since we are not dealing with negative time. Much more difficult. If you find this video useful or interesting, please like and share. You may also consider subscribing to this channel. Now we are going to look at one more question, but it has 5 parts. Example 3. A bullet of mass 32 grams is fired vertically upwards with a velocity of 185 meters per second from the edge of a vertical cliff 75 meters high. It travels to its maximum height, then it falls to the sandy beach at the foot of the cliff and sinks 25 centimeters into the sand. Ignore air resistance and assume that G is 9.81 meters per second squared. Calculate 1. The time it takes to reach that height, the highest height, the height to which it will travel, its velocity just before it hits the sandy beach, its kinetic energy just before it hits the beach, and its rate of deceleration while it travels in the sand of the beach and come to a stop. Alright, sounds complicated. So let's make a simple line drawing to help us to better understand the question. So here is the cliff. Bullet is fired vertically upwards. It goes to its highest point there. It stops temporarily, and then it falls, reaching back the level of the cliff, going further down 75 meters until it reaches the sandy beach below, and then it sinks 25 centimeters into the sand. So here are our 5 questions. Part 1 and 2 will deal with the bullet going upward. Parts 3 and 4 with the bullet coming downward. And part 5 with the bullet traveling through the sand. Once we understand that, the question becomes fairly simple. So let's look at part 1 to begin with. The time it takes from A to B. From the time you fire it, to the time it reaches its highest point. What do we know? Well, we know that the initial velocity is 185 meters per second. We know that the final velocity is 0 meter per second because it will stop when it reaches its highest point. We know that the acceleration, which is gravity, but since gravity is pulling against it, we will let that be negative. and we want to find time. Again, we look at our equations. Can we use the first equation? We know V, we know U, we know A, we want to find T. Yes, we can use the first equation. V is equal to U plus AT. Make T the subject of the formula. T is equal to V minus U over A. Substitute the numbers we are given, and we get T is equal to 18.858 seconds. By now you know that you cannot leave it as that. We have too many significant figures. The numbers we are given have three significant figures, 185 and 9.81. So we will have to round off the three significant figures, which will be where this 8 is. So that will give us a time of 18.9 seconds, and that should suffice for CSEC. We do have our three significant figures, and we have shown that we have rounded it off to that. But just to make sure, you can always say 18.9 plus or minus half of this position, which is 0.05 seconds. So we got the time it takes to reach from A to B, the highest point. Now we want to find the height, the distance from A to B. We know that U is 185 meters per second. That's the initial velocity. We know that the final velocity is 0 for the journey going up. We know that A is negative 9.81 meters per second squared, and we just found that the time is 18.9 seconds. We want to find S. Let's look at the formula we have. Let's look at this first one that has S in it. Do we know V? Yes. Do we know U? Yes. Do we know A? Yes. So we can use that, but then we will have to change the subject of the formula. Let's look at formula 3. S is already the subject of the formula. Do we know U and T? Yes. Do we know A and T? Yes. So we will use formula 3. S is equal to UT plus half AT squared. We substitute the numbers we are given, and we get 1744.38 meters. We have to round off the three significant figures, which will be 1, 2, 3. So we will get 1740 meters. That may not be sufficient for CSEC. We may need to add plus or minus 5 meter, indicating that we are rounding off at the tens position. Note, you could have used equation 2. Since we know V, we know U, and we know A, and we want to find S, but that would require changing the subject of the formula such that S becomes V squared minus U squared over 2A. You substitute the numbers you are given, and you will get back this same answer here. So we have solved part 1 and part 2. How long will it take to reach to the highest point, and how high is that highest point? So we did those two questions, that and that. Now we will look at part 3. We want to find the velocity when that ball hits the sandy beach here. Initial velocity is 0. We will consider the height that we calculated, because we will need to use that. So that will be that height plus this 75 meters. So we know that U is equal to 0 meter per second. That is to say, when the bullet falls, its initial velocity is 0 meter per second. Its acceleration is 9.81 meters per second squared, and that is a positive 9. We know the distance is the 1744 that we calculated here going up, plus this 75, and we get 1819 meters. We want to find V. We look at the equations we have. Well, equation 3 does not have V in it. Equation 1 has V in it. But can we use it? We can't, because it has t and we don't know t for this. So we will look at equation 2. We remove the square from here on the left hand side and we get v is equal to the square root of all of that. We substitute the numbers we are given and we get 188.9 meters per second. We have to round off to 3 significant figures and we have to round off here. So we get 189 meters per second. That should suffice for CSEC. But if you want to make doubly sure, you can always add half of this position where you are rounding off and say 189 plus or minus 0.5 meters per second. We want to know the kinetic energy just before it hits the beach. That is to say, we want to know the kinetic energy at this point. In this case, we will not have to use these equations because none of them deals with kinetic energy. But you do know that if we know the velocity and we know the mass in kilograms, then we want to find the kinetic energy. Kinetic energy is equal to half mv squared, and we have looked at that equation before. We substitute the numbers we have, remember v squared, and we get 571.54 joules. We have to round that off to 2 significant figures because the number with the least significant figure is 32 grams. That's 1, 2, and we get 570 joules. That may or may not satisfy CSEC. So just to make sure, we will take half of the position at which we are rounding off, and we will say 570 plus or minus 5 joules. That 5, of course, came from half of this tens position. Now we have to do part 5. Part 5. In this case, for this part of the journey, the initial velocity is now 189 meters per second. Now, for the part of the journey from B to down here, that was the final velocity. But that's from B to C. Now, from C to D, the initial velocity is now 189 meters per second. The final velocity, the bullet will come to a stop, so it is 0. The distance we know is 25 centimeters or 0.25 meter. Note again, 3 significant figures, 2 significant figures. Our answer can only have 2 significant figures. So what do we want to find? We want to find A. Let's look at the equations that we have, the formula that we have. We have A here, but we don't know T, so let's pass that one. This one has an A here. We know U, we know V, and we know S. So we can use that. This other one has a T in it. So we are left with formula 2. V squared is equal to U squared plus 2AS. We will change the subject of the formula and make A the subject, so that A is equal to V squared minus U squared divided by 2S. We substitute the numbers we are given and we get this divided by that, and notice we get a negative 71,442 meters per second squared. But remember, that is acceleration. A negative acceleration actually is a positive deceleration. So when you do a question like this and you get a negative answer, that means that the acceleration is negative. But that also means that the deceleration is the opposite of that, which is positive. So that we will do 2 things with this number. We will change that negative to positive, and we will round off to 2 significant figures, which gives us 71,000 meters per second squared. Just to make sure, we can say 71,000 meters per second squared plus or minus 0.5. You cannot go wrong if you do this. And so basically we have worked through all 5 parts of that one question. So we have just completed equations of motion. Be on your lookout that if you are dealing with upward or downward motion and gravity comes into play, when the object is going upward, gravity is negative 9.81 or 10, and when the object is coming downwards, gravity is positive. So out of these 17 equations, we have completed 15, and we are only left with these 2 to consider in the next video. And that brings us to the end of Physics 09, Equations of Motion.